Well, hello everyone. As you can see today on the workbench here, we have a Black & Decker R0100 random orbit sander. And the issue with this unit here is that it's actually my personal one. I've owned it for numerous years now. Maybe 12 or 13 years. It's very old, very beat up, as you can see. The dust bag has been lost a while ago. I've taken this ring off in advance because today we're going to be tearing this thing apart because it does not work at all. Suddenly, one day, a while back, maybe 3 years ago before the pandemic hit, this thing stopped working all of a sudden one day. I believe the thing was that it just would not turn on. So let me get the cord all entangled here. We'll plug it in. Initially, before this video, on this plug here, this plug had become corroded on the neutral lead, and I polished it all up. Interestingly enough, it seems to be made of some sort of different metal compared to the hot prong on the cord. Very interesting. But anyways, here's what it does when you plug it in, or here's what it does when you plug it in and you turn it on. Absolutely nothing. Bang it, does nothing at all. So let's go ahead and start tearing this thing apart in anticipation that the issue might be, and also the main reason why I polished this prong here on the outlet, the neutral prong, was because I thought maybe because it was so corroded there was a bad connection in the outlet and it couldn't get any current or get anything to flow back out of it. So that was the reason why it wasn't working. Anyways, so first start off and see. First thing I like to do whenever something is not working is check to see if we have a complete circuit going through it. And since I polished this prong, we should be able to get an unbiased reading. So let's go ahead and set it to the continuity mode. Let's turn it on. In theory, there should be a complete connection. Whoops, I touched the leads together. However, as we see, there is not one. So that tells us that our switch could be bad, or the motor could be burnt out. I don't believe the motor is burnt out because the last time I used it, it worked fine and it's never overheated. So let's go ahead and put the multimeter over to the side now. And in anticipation for this video, again, I've already unscrewed all the screws. So we can just sit it on its side here and open it up. Make sure I don't lose that ring if we get the thing working. There we go. We caught on something. Oh, the switch has stayed on this side of the frame. There we go. So here we are. Just do a quick visual inspection. It does not appear that the motor is bad at all. So you can see the windings are the bright copper color. Bearings are good. I think this is what's called a sleeve bearing up at the top. But as you can see, the brushes are good in there. And everything seems to be okay. The windings in the middle, they seem to work fine. So let's go ahead and start digging a little deeper. Well, the first things that I'd like to do is to go ahead and check with the multimeter the switch, because if the switch is bad when it's flipped on, we should have no connection between the input and output of the switch. So Oh, it was already on. Okay. Let's go ahead and check. Between the first and second. Oh. Okay. So, we switch it off. Alright. So our switch is working. Very interesting. So, what that could mean is that our power cord is bad. One thing you will notice is this strain relief here is kind of all mangled up, so that may be part of the problem. So, let's go ahead and check between each of the leads. Let's go ahead and test the neutral one first. As we see, the neutral one, as soon as it exits the cord, it goes to this winding, this field winding here on the universal motor. So let's check that. Okay. I bet it's the hot wire that has gone bad. So let's go ahead and check that one. The hot comes out and immediately goes to the switch. All right. No. Okay, so the cord is good. You know what? Let's just make sure it's not a short. Okay. Yeah. Everything seems to be alright so far. That's very interesting. So that must mean that the problem is within the motor. I do know that sometimes the field windings here, they do tend to get a bit jacked up sometimes, these field windings. So let's go ahead and test the field windings. This field winding right here, a bit of crap right there. This field winding right here appears to be wired here and here, so let's go ahead and check it. Okay, and it may be the leads that I'm checking. Okay, good. That's not shorted out at all. Alright, that one's good. Let's see. The other winding, field winding, is behind it. So let's go ahead and check that one as well. Oops. Let's go ahead and prop it up on the back plate here. There we go. So let's go ahead and check that one. Okay, that one's good as well. Make sure they're not, I'm just going to see if they're shorted at all. No, okay. No, and we're good there as well. It's very strange. Do the brushes have the brushes making contact? Let's see. Oh. Saw something on the multimeter. What I'm doing is I'm putting one lead on the brush and then the other on the commutator bar it's touching. Okay, so that is working. The brushes are making, that brush is making contact with the commutator. And let's check this one. That's kind of odd. Let's see, it's touching that one. Try and measure it again. Okay. So I am touching the brush, and that one is making contact as well. Very interesting. And yet, this thing still does absolutely nothing. go ahead and just put it back together, you know, just see if it'll work. No. How odd. Makes no sense to me. You guys are probably wondering the same thing. Man, this thing's always such a pain to get apart. There we go. So what could be the problem then? Spins fine. Huh. Let's see here. You know what? I think it doesn't. I don't think that any of this is. Yeah, this is just held together by the case. So I think. Oh yeah, we can. Let's go ahead and take out the armature and see how stuff is looking. Okay, so that bearing down there is fine. This bearing there is fine. This is what I was talking about, like this. Look, I think it's a what's called a sleeve bearing. It's just fits on top of there. Yeah, you see, not the best. But if we look in here, there's definitely ample brush still left. Interestingly enough, there seem to be like chips on the brushes there. If you see that. And you see right there as well. They appear chipped, so I don't know if that's contributing to the problem, but they looked like they were touching the rotor pretty good. Let's see if we can get a better look at this field winding here. I don't know if there's a thermal overload in this thing that tripped or what. I don't think these brushed AC motors have thermal fuses in their motors. But yeah, nothing appears to be inherently wrong with this field winding. And oops, gotta get this back together. I've always found that very interesting how the power tool manufacturers, they don't have really, like, if you will, dedicated motors. We lost the brush. For their power tools, everything's just kind of made in the housing. It's unfortunate this brush has fallen apart. Thought there was supposed to be some end stops on these that would prevent that from happening. Anyways, I'll come back when I've sorted this out. Alright, well, I got the whole brush thing worked out. Turns out it just fell off the spring, which is why it was not staying in its brush holder. But it's perfectly fine now. Thought these brushes were non-replaceable. Very nice to see that they are. If I'm able to get this thing working, but I'm a bit stumped as to what is exactly wrong with it. Let's see if I can get this thing back together. Oh, I see. Alright. There we go. Good as new. And in the process of doing this, I accidentally disconnected this wire right here. So we'll just need to fix that. No big problem. And actually, I don't know if that wire was disconnected already. Don't believe it was, but you know, never hurts to just see if it's going to work afterwards. Let's just get that in there. There we go. Alright, it's in now. Now we just get all this back in place. There we go. That's in. And now just for this other brush holder. There we go. Back together. So, clearly what's going on here is alright. Everything there is alright. So now we'll move over to the armature. I mean, the commutator looks perfectly fine, to be honest. You can see it's pretty good, in pretty good shape. I don't know. What the heck? There you go. That's what's wrong with it. Check that out. Look at that commutator. Look at the wires. Yeah, this thing is done. Wow, that's so sad. Something must have got in here and then destroyed everything in there. Well, that's that, folks. Looks like need a new commutator. I have other sanders already. There's a model number if you want to check that out. R0100. But yeah, I guess that's it. What a disappointment. So, I guess this thing is just gonna end up in the bin. Whoop. So I guess I'll just put it back together one last time here. See if I can do this on camera so you guys can see what is going on here. Man, that stupid brush fell out again. Okay, so now that I've gotten the brush back in, just lift this side up first. Oop, where did the bearing go? Okay, let's put the bearing back on now. Slide that side up first. Both of them, lift it up. There we go. Oops, but I forgot to put on this little seal here. Let's go ahead and get that on in its correct spot. There we go. So yeah, looks like that's all for this sander. One thing that's interesting to note, which I didn't know before, which I discovered when playing around with this thing, how these things work is they don't actually spin this disc around. What they do is, as they rotate, you'll see it moves around in a circular motion like that, and it pretty much shakes the disc around, and that action of shaking it helps to move the disc around, and it creates friction, and that's how it sands. So with that, thank you all for watching. Looks like a repair on this thing may not happen after all. So yeah, thank you all for watching.